Hey everybody, this is Jake Shoemade with my Chem 4 week discussion. Decided to do it via this recording. Hopefully it works out all right. Um, so just a little bit of a fun thing here with the PowerPoint or whatever you want to call it, just to kind of go through each of these steps here. So, all right, so let's talk about what made sense to me. Honestly, chemistry is quite hard for me, and I'm trying to understand the best that I can. I've been out of school a while. It's been a while since I've taken a chemistry class, and but what made the most sense to me is the ideas that where chemistry came from, and that chemistry is the basis of all things on Earth, from our digestion to the way our brains work to the making of medicines and even the manufacturing of gasoline. So it's all chemistry, and so the textbook did a pretty good job of in the intros of each chapter just talking about what each just kind of some very practical what is chemistry all about. So for me it looks like this. The idea that in the basics of chemistry, things like mass and volume and the law of conservation really made sense to me, and that there's physical and chemical properties. And so that's all a part of what I do for a living. So I'm a firefighter, and I need to know a lot about chemical changes. I don't think I would have called it chemistry until now. But things like flammability, combustion, corrosiveness, pH, these all come, in the factor with structure fire. So that's one of our fire engines there, putting out a pretty big house fire. Um, Recently, we've had a lot of electric car fires. We've had electric bike fires, and so understanding the chemistry behind that is really interesting. What creates that ignition, and then also what happens inside of the structure when something burns, and so what comes out of it, and just the idea that really nothing is, it's not really, but that there is nothing lost. And so the heat and the smoke and the ash, those are all just changes of kind of what that whatever the thing is that's burning. And so here's a car fire that I was on. You're going to see my picture here in a second. So I ask, in my life, I always ask, how does this apply to me? And so when I started this chemistry class, it felt like, how in the world am I going to understand this chemistry? Because it feels very disconnected. And so when I started reading some of these things, I thought, oh my gosh, it actually really does apply. Um, and so this is a very practical example for me in my line of work, that something catches on fire, like this pickup truck caught on fire, and what happens to it. So maybe you've never seen a big fire like the one in the slide before, or maybe a car fire like this, but I'm sure you've sat around a campfire, you've had a fire in your fireplace, and kind of where does that wood go? Where did this car go? Where did those parts go? Even a candle burning. Okay, what happens with that? So here's the next slide. That's me with the hose line and the black helmet there. But it's very interesting because the fuel here is converting. It's going through a chemical change. Its heat is created, and this is a real practical idea that in chemistry nothing is created or lost. This is called the law of conservation. So kind of interesting here. All right. Next thing though, what am I struggling in? So at least we're not blowing ourselves up. But for me, kind of one of the big things is we have strange names of unknown items. And so for me, when I was in paramedic school, it was very practical in the sense of, okay, the heart, and this is how the heart works. And even when we got onto a cellular level, how meds work and things like that, I was really able to see how it applied in my job. So, or to become a paramedic. The hard thing with chemistry is these are words and terms and ideas that I really have no idea what they mean or how they apply. So I have ADHD. My brain has a hard time remembering things, strange things, and one thing means three different other things. So kind of what I decided to go through was basically just kind of a basic reminder for me of all of the parts, like of sodium, and what of each of those things mean. So I thought I'd go through that. Here's the periodic table with all these crazy numbers on there and letters, and what does it mean? How does it actually, what are all these things translate to? So let's just kind of go through a few of these things here. So the isotope name, for example, so I just chose sodium because that was pretty easy. And so what we're looking at there is, so that's the name, the Na. It's the same thing as sodium. And then the 22 is, that's that mass number. You can't see it underneath me because my face is right there, but that's what's showing underneath. So, and then as I keep going, we're just going to see that, oh, there's other things that those numbers relate to. So how about like what's the chemical symbol with the net charge? Like what in the world does the net charge mean? So really understanding, we have that there's going to be one, so there's 11 protons and 10 electrons, and when we subtract those things, that gives us the positive. And then the funny thing about the sodium is it's just a plus, and so the idea that we have to remember there's actually a one there. So it's not just that, we're going to look at other, if you looked at other elements on the periodic table, that you see, oh, there's different numbers there. And so sodium I thought was interesting because it's one, but they just put positive instead of plus one. All right, so there's the atomic number, which is also the number of protons. All right, so that kind of goes together. Easier to find on the periodic table, but to think, okay, for me to remember, okay, the atomic number also equals the number of protons. All right, and then here we go. Here's another number on the periodic table. What in the world does that mean? So that is the mass number, but the mass number, what that equals is the neutrons plus the protons. Like, oh, okay, and then we're going to round that up. That 22.9 is going to be 23. So again, having to remember, okay, what does that number actually mean? So difficult for me to remember because, okay, what does it actually mean, the number of neutrons and protons? Well, let's talk about neutrons. So this is kind of interesting that the neutrons, it's the atomic mass minus the atomic number. Whew. More stuff to remember. Numbers that, again, don't mean anything to me in my practical day-to-day life. So it's just hard for me to remember that that the number of neutrons is the atomic mass minus the atomic number. And we're going to talk about electrons here. All right, so I had to look up electrons to try to understand. So this is complicated in my mind. So if it's a neutral atom, the number of electrons is equal to the proton number. If it's positively charged, the number of electrons is found by subtracting the charge number from the proton number. And then if it's negatively charged, the number of electrons is found by adding the charge number to the proton number. Again, hard for me to remember all these different steps kind of on each of these things. So chemistry is quite a stretch for this old guy trying to get through it. So anyways, there's my video for this week on what I seem to understand, which is the practicality of my job, which a lot of it has to do with fire and combustion and understanding kind of the basics of chemistry there. And basic hazmat and things like that. But then when it comes to all these little numbers and what does that actually mean, I'm really struggling trying to comprehend that. So hope that helped you out. Thanks so much.